Human beings have been trying to figure out the cosmos ever since the 16th century, and we might think we've learned everything there is to know by now. Everyone, including the world's most brilliant scientists, was taken aback at that point. It turns out that our entire solar system is engulfed in a giant bubble, including the far-off Oort cloud, which is a light year away from the Sun. It has a radius of 500 light years. What's more impressive is that our Sun is practically the middle of this bubble. Do we live in a giant bubble? Welcome to Cosmos Observer, where nothing goes unobserved in the universe. The scientists at the Harvard-Smithsonian Center for Astrophysics, CFA, have confirmed that we are indeed living inside a bubble. They ran the most complex computer simulations possible, reconstructing space and time in 3 dimensions. According to the study, the Sun and Earth are almost in the center of a giant bubble with a diameter of 1,000 light-years, which they call the local bubble. The researchers created a 3D map of the local bubble surface. They calculated the trajectory of the 7 main star-forming regions that make up the bubble's skin using data from the European Space Agency's Gaia space observatory. It began to form around 14 million years ago, according to calculations. About 15 supernovae must erupt over 1 million years to achieve this. With the pressure of light, a series of explosions pushed interstellar gas outward, forming a bubble-like structure with a dense surface at the boundary. And the bubble is still growing in size. Surprisingly, they discovered that it's the primary reason for our unusually rich neighborhood of young stars. According to data collected by the Gaia Space Observatory, the bubble expanded at about 60 miles per second when it first formed. The bubble is still growing at a rate of 4 miles per second. Scientists have devised a new model for the heliosphere, the bubble that surrounds our solar system. The shape of the bubble that surrounds our solar system has been revealed by NASA, a deflated croissant. Using data from NASA missions, scientists at the US Space Agency have developed a new prediction of the heliosphere's shape. The heliosphere is a vast region that wraps around the Sun and encompasses all of our solar system's planets. It protects the planets from galactic cosmic radiation by acting as a shield. The heliosphere has long been thought of as having the shape of a comet with a rounded leading edge known as the nose and a long tail trailing behind it. However, new research from the Voyager spacecraft, the Cassini mission to Jupiter, and the New Horizons mission to Jupiter and Pluto suggests that the heliosphere is more like a crescent than a comet. Scientists used NASA missions data to characterize the behavior of the material in space that fills the bubble on the heliosphere and maps its boundary, including particles flying towards Earth, particles trapped in Saturn's magnetic field, and particles bouncing back towards the inner solar system. The heliosphere's shape is also a piece of the puzzle in the search for life in the other worlds. The harmful radiation from galactic cosmic rays can render a world uninhabitable, but our solar system has escaped this fate thanks to our strong celestial shield. According to lead researcher Catherine Zucker, the findings contribute to a better understanding of how star-forming regions form, a NASA Hubble Fellow at the Space Telescope Science Institute in Maryland. Zucker said that the supernova have swept up gas into dense clouds that eventually form new stars. She's confident that the work provides the most substantial observational evidence to date supporting this theory. The Earth is currently at the center of the local bubble, but that isn't what makes this location unique. The Sun is centered inside the bubble by chance, noting that the Sun was about 1,000 light-years away when the bubble first began to form and only entered it 5 million years ago. According to the Copernican principle, our planet's location inside the local bubble suggests that superbubbles are likely very common throughout the Milky Way, which states that humans are not privileged observers of the universe and that Earth has no special location in the galaxy. These bubbles interact with star-forming regions occurring where bubbles intersect. As a result, the Milky Way resembles a very holy Swiss cheese with holes blasted out by supernova and new stars forming in the cheese around the holes left by dying stars. The team discovered that the solar system will not always be trapped inside this bubble. In about 8 million years, the Sun should exit the bubble. However, the bubble may no longer exist at that point. According to Zucker, the local bubble's expansion is slowing and will eventually disappear once it reaches its maximum size. The local bubble is nearing the end of its life cycle and will not continue to expand indefinitely. Its expansion rate has plateaued. The local bubble will eventually slow down to the point where it'll merge with the ambient gas in its surroundings. According to Alyssa Goodman, an astronomer at Harvard and the Smithsonian Center for Astrophysics and the study's author, the team's findings are an incredible detective story driven by both data and theory. Goodman is also the creator of GLUE, a data visualization program that aided in the discovery. The researchers hope to use their software to 3D map interstellar bubbles deeper in the universe in the future to continue unlocking the secrets of interstellar bubbles like the local bubble. Supernova models, stellar motions, and exquisite new 3D maps of the local bubble material can all be used to piece together the history of star formation around us. However, one might wonder where these bubbles collide. What is their relationship like? How do superbubbles in the Milky Way drive the birth of stars like our Sun? All these questions are yet to be answered.